Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at bitmap file headers. So in this and the next tutorial, it's going to be a little bit boring because we're going to have to construct a load of information, two separate chunks, that have to be written to the top of every bitmap file. Now, excuse me, the way I discovered how to do this was by Googling for bitmap file format. But if you do that and you get up a document that explains the bitmap file format, it doesn't really exactly make it easy to figure out exactly what you should put in your bitmap file for your particular purposes. So I also Googled for example code, and I found 2 or 3 separate lots of example code for creating a bitmap, and I use those as a guide to creating my own code. So that it's not that after some years you know all this stuff automatically off the top of your head, unless you're working with bitmaps constantly in detail. It's a really good thing to do to Google for example code for how to do this. So we're going to start with a bitmap file header. So we need to write a bunch of bytes, and we have to get this exactly right to the top of the bitmap file in order for it to be a valid bitmap file. And to write those bytes, we could just write them all in a method somewhere or in a function. But what I'm going to do is create a struct that has the exact same bytes that we need to have at the top of the bitmap file, and then we can fill in the struct and write the entire struct to the top of a file. So I'm going to start here by right-clicking my project and go to New Header File. And I'm going to call this bitmap file header.h, and we'll click finish. So this is automatically giving me the sort of multiple include prevention things in my header. If you don't get those in your IDE, you'll need to type them. And this is just an if statement in the C++ preprocessor language. So the preprocessor runs before your code is actually compiled, and it just kind of textually rearranges code, includes all the headers into the right places before the file is compiled. And this is just saying if this, which is just a made up string that could basically be anything as long as it's unique, if that is not defined, then we define it, and we're going to paste, it's going to ultimately paste into your code all the stuff that you write here, and then it's the end of the if. So that means if you've multiply included a header file, which is really easy to do by mistake, or just because you've included the header file in multiple different CPP files, and some of them somehow end up with multiple inclusions of the header, or you can include a header within a header. Anyway, however it happens, you can easily end up with including your header multiple times. So whatever code is we're going to type here would get included multiple times in CPP files, which will be redefining it, and that's not good. So this all just prevents that from happening. And I mentioned that in my beginners course, but I just wanted to mention it again quickly here. So we're gonna create a struct here, and we're not gonna see anything new when our program runs, but we should be able to compile it without any syntax errors. And maybe it's a good idea to start by going to our hello world thing here and just saying include, and we'll include that file we just created, bitmap file header.h, to make sure that this file gets included. Okay, so we go to bitmap file header, make sure it gets actually built and the syntax checked. Okay, so we're going to have a struct here, and I'm going to call it bitmap file header. So the only difference you may recall between a struct and a class is that, help if I get the brackets right here on this keyboard. Can I remember where they are? Okay, so the only difference between a struct and a class is that the members of a struct are public by default, and members of a class are private by default. And we want to access the members directly here for efficiency, and this is not going to have any methods, so it's better if we use a struct, or we could just as well use a class and just put public at the top, that would be exactly equivalent. So we need the semicolon there, of course. I'm going to refer to my notes here because this is not information I carry around in my head. The first thing we need to end up in our file is going to be 2 bytes containing the letters, or the numeric representation of the letters B and M, and that just tells the application that opens this file that it's a bitmap file. So I'm going to write here char. I'm going to use a char array, and I need brackets here. There we go, finally found the right thing. So it's going to be a 2-element array. And because I'm using C++11, I can already initialize this. If you're using a previous version of C++, then you would have to do this in the code where we actually use it. So we're going to have to set some of these data members in the code when we actually use this struct. But because it's C++11, I can initialize this here. So in single quotes, I'm going to put a B, then a comma, and in single quotes, M. So we're going to just have 2 bytes there with the equivalent of these letters in. So that goes right at the top of the file, and then we need int file size, which has got to be the size of the final file, which we're going to have to fill in later. And in fact, rather than use int here, we need to make sure that this is 32 bits exactly. It's got to be 4 bytes here, this thing, precisely, to get the file format right. So if you've got 32-bit ints on your machine, you could use an int, but to ensure code portability on different platforms, different compilers, and to really make sure it is 32 bits, it's going to be better if we use an integer type that's guaranteed to be 32 bits. So to do that, I can say include C standard int, and also using namespace standard. So if that doesn't work on your compiler, it probably will, but if it doesn't, you need to Google for example, Visual C++, 32-bit integer, something like that, and find out how you can define a 32-bit integer for your platform. But this should work with most compilers, including hopefully Visual C++. Now we can use the type int32_t. So I'm going to use that instead of int, because all this is an integer that's guaranteed to be 32 bits. And we need to be picky about exactly how many bytes we have at this point, because this is going to be written directly to the file, and the file has a fixed format. Then we're going to have an int32_t reserved, which is not used. If my voice is getting quieter and softer here, it's because I'm leaning over to check my notes, which I don't normally use, but here I really can't remember this stuff off the top of my head. So I'm just going to initialize that to 0, and again, you could do that in the code where you actually use this if necessary. And finally, we've got int32_t data offset, and we have to set this later. And that says how long into the file the actual data actually begins, as I recall. So now we've got that, we've included it in our Hello World program here. So we should be able to compile that. So if I hit the compile button here, the build button, or you could just go to project build project, then you shouldn't get any syntax errors. You need to get rid of any syntax errors you have there. And if we run it, we should just see the hello world that we saw before, basically. That's it for this tutorial. In the next tutorial, we're going to look at the second chunk of data in the file, which is even more complicated, but it's going to be similar to this. There's actually one very, very important thing that I've forgotten, which we still need to add on. Because the thing is, C++, if you have a struct like this, it will align the data with padding in the way that's most efficient, and we can't allow that here. We need to tell it to pack the data so it looks exactly like this, because we're going to write this literally to a file. And to do that, we need to say pragma. So this is another preprocessor directive, pack round brackets 2, no semicolon, because it's a I can't say that word, preprocessor directive, just like these are. So, and include, so they don't end in semicolons. They're not C++ statements. And what this does is it makes C++ align all of these on 2-byte boundaries, which is fine. So 2-byte boundaries, rather than putting extra padding in to align all these in what it considers the most efficient way possible. And that's basically going to mean, if we just say this, the bottom line is, then this struct will be kept in memory exactly as it looks here. There'll be no hidden padding in there. And if you don't do that, then your final bitmap will be unreadable, because there'll be extra padding bytes behind the scenes within this struct. Okay, so that's it for this tutorial. Until next time, happy coding.